So let's look at 1E, which gives us the same data as before for number 1, normally distributed data with an average of 3, a standard deviation of 0.5. And the question that part E is asking is slightly different than before. It's not asking for a probability. When the problem asks for a probability, make sure that you're providing an answer that is within the probability range. Essentially, 0 is less than or equal to your probability, which is less than or equal to 1. This one is asking for an amount of time as the main question. So if you follow what we did before, let's take a look at the previous example just for a moment. What we're trying to find is the area of this shaded region, and that's what translates to the probability that a data value is going to fall in this range less than 1.9. And that's the connection between the normal distribution and a probability. So what 1E is asking is for us to find this data value, right? Instead of giving us this data value that borders your shaded region, we're trying to find that data value that borders your shaded region. So in order to do that, we have to know how large this shaded region is. And this shaded region is going to be given to us by the problem. The lowest amount of time someone spends looking at their phone and is in the top 17%. The word top is important because that essentially tells us which direction to shade in. The top portion, remember, the normal distribution is centered, or it sits on top of a number line, essentially. A number line that has infinity at the right-hand side, negative infinity at the left-hand side. So top means towards the right because those are the greatest values, those are the highest values. So we have the top 17% over here. 17% translates to a decimal of 0.17 because we divide by 100 in order to get that. So that makes this normal distribution here split into two separate categories, two separate regions. One of them has a size of 17%, which means the other one has a size of 83%, or rather 0.83. And this is important because our inverse normal distribution function, which we're going to use in order to calculate this data value, our inverse normal distribution function wants us to put in the area to the left of this data value, not the area to the right of the data value. So by finding and declaring this as 17% based on what we're being told, we have to subtract that 0.17 from the number 1 in order to get this 0.83 size of this unshaded area. So let's take a look at where we can find this inverse normal distribution function. Hit second, VARS, which again brings us to the distributions. Choice number 3 says inverse normal, so let's use that. And it asks for an area. And again, it doesn't say it, but this is what the calculator wants. It wants the area to the left of your data value, regardless of what the problem says, regardless of what you shaded in based on what the problem says. So 0.83 is the area, has to be put in as a decimal. 3 is the average. And 0.5 is the standard deviation, just like before. And we'll hit enter. And remember, this is not a probability answer, right? So the answer we're getting is an element within the data set, in this case, 3.477 is this number right here. Number 8 on the review sheet, if I can jump forward, is the same type of problem, but I wanted to show a different data set. This one has a data that records the heights of men normally distributed with the mean of 69.9 inches and a standard deviation of 3 inches. So what is the tallest a man can be? Fall in the bottom 20%. So we're given the percentage 20, but instead of it being at the top end of the normal distribution, it's asking us for the bottom end of the normal distribution. And that means when we draw our normal distribution, we are shading in the area to the left of this data value. And one thing about the size of the shaded region is that if you were to cut this normal distribution in half at the average that you're given, what that means is that the left-hand side is 50% of the data. And the right-hand side is also 50% of the data. So if this shaded region is supposed to be 17%, and it's supposed to go all the way to the right, that means your cutoff has to be somewhere on this side of the average. Since our shaded region is less than half of the normal distribution, and it's supposed to cover the bottom portion, that means our cutoff location has to be somewhere to the left of the average, right? Because again, this is the 50% marker right here. So from the left-hand side, if your shaded region is less than 20%, that means it has to get cut off somewhere here, which makes the unshaded region equal to 80% or 0.80 once you convert these into decimals. 20 divided by 100 is equal to 0.2. It's the same as 0.20. So again, the inverse normal distribution wants the area to the left of your data marking value, which in this case is equal to 0.2. So let's hit second vars, go inverse normal, 0.2 this time. This one has a mean of 69.9 and a standard deviation of 3. So we'll put that in separated with a comma, the button above 7, and we'll hit enter. And we have 67.375 as our data value right over here.